All right, there we go. All right, we're going to move on to new stuff this week, finally. Hooray. You're super excited. We're talking about streams, which is fancy way of talking about files. I don't know why they named it this way. Um, we'll get there. It's okay. So this is chapter 6 in Zybooks. Hopefully you're following along, keeping up. Again, I'm not going to check to the end because it's just a lot of work to check all the time and to enter a bunch of things all the time. So uh, do try and keep up though. Those Xylabs especially do add up. So if you've not gotten through the first 5 chapters with all the exercises and the Xylabs and all the good stuff, make sure you work on that. It's a lot of work, which is good because it'll feel a little bit annoying, but the more you practice, the better you get at it, like anything else. So lots of practice there for a reason. So we'll get into streams. Next week, Monday, we'll do the midterm review and then talk about the solution to project 2. And then next week, Wednesday, we will have time for the midterm. I know not everyone's a morning person. I'm especially not a morning person, and I still count 11 as the morning. Um, so my plan for the midterm is that it will open at 11 a.m. and then you'll have any time that you want to sit and take it for your hour 15 block up until 10:30. So whatever's good for you, you find a time that 5 days, right, between 10:25 and 10:30, when you've got an hour 15 that you feel good, and you can click start. Okay. Uh, I'm going to assume you guys will not work with other people. Right? We can all agree this will be our individual effort. It is open book, open notes, open internet, but it's an hour 15. So if you don't have any of it in your head or even know where to go look, it's going to take you a lot longer. Right. So the idea is know where to go find the information. You don't have to memorize anything. Okay. Like no one gets paid to memorize stuff in software. No one's ever told me on the job that I have to do something off the top of my head because that'd be stupid. Right? We're going to use our tools. It's perfectly fine to use your tools, use your resources, but you have to know where to go look. So everything should be coming out of the Zybooks and our lecture stuff. Right? That was our main source of here's the stuff we're talking about. So we'll have half the quiz. It'll be true false questions essentially. I don't really like multiple choice. I might have like short answer, like a fill in the blank style, short answer style. So I'll give you last year's midterm on Monday, or maybe even on Wednesday, because then we can talk about the answers on Monday. I'll do that. So on Wednesday, remind me, I'll post last year's when I did the midterm here. I'll post that one for you so you can see what the questions look like, kind of get a feel for how they're formatted. And then it'll be 3 short, long answer style programming questions, right? So one on functions, one on loops, one on streams, right? So hey, it'll be a short little thing. Again, the goal is that takes you maybe 15 minutes or less, right? Or 20 minutes or less. So if you did 3 of them, that'd be about an hour or so and leave you 15 minutes for the true false fill in the blank style questions at about a minute each. That's sort of the goal. So uh, again, I'll give you the practice one. You should feel pretty good. Anytime between 10:25, 11 a.m. and 10:30, 11 a.m., take it when it's good for you. Uh, you will just agree that you will not work with other people, and I'll trust you. Okay, because yes, and if you guys do work together, it ruins it for everybody, right? And then I can't do this anymore. So we'll just agree not to, because it'd be a big sad to have that happen for everyone. So all right, and then after that week, we get into the last couple new topics, chapter 7, 8, and 9, and we're done. So we're like looking near the end of the semester already, believe it or not. After we hit midterm week and come back, just a couple new topics here. Um, we've got December set aside for you to work on the final project. Um, I'd love for you folks to do it in pairs. It's not required in this class to do group work. Um, I think working with someone else, usually you get a better product. It does add a little bit of effort, which is interesting. Like working with someone actually makes it take more work because you have to do all that coordination stuff and you have to work together, figure out who's doing what, and talk together. So it's the same project whether or not you do it individually or with a partner because it's about the same amount of work, right? Even if you're trying to divide it up between 2 people, you still have the extra collaboration work there. And then instead of a final exam on 12/11, you guys just get to present your projects. So it'll be your turn to get up in front and hit run, show us your project. We'll maybe ask a couple questions about the code. Pretty quick, maybe 5-10 minutes tops. We'll get through it. It's not too bad, I promise. I don't know where that is yet. They probably in the regular room, but they've assigned those separately, so that's always fun. But ideally, if you can get it done by 12/6, then you've got nothing to worry about for finals week. So we'll have some time there. We're going to start at 11:15 or so. So you have about a month to work on that one. And again, the final project is the bulk of your grade here in the class, right? That makes up 40% of your overall score. So this is a significant portion here. The idea is if you don't do this, you don't pass the class. Right? This is the summation of all the things we've done in the class in one final little package. It won't be anything super amazing because this is our first class, but it'll be something interesting. I would like to imagine, and should be fun by the end. Okay, so that's sort of the plan. Working towards the end of the semester here. So let me fire up Visual Studio. I love streams and files because this is the first time we get to work with data that I don't have to just sit at the console and type in. Right? When I hit run, I can actually go read a file and get information out of a file, or I can write information to a file so that I have the data somewhere when the program stops running. Right? Everything we've done so far has been working off of data in memory. Right? It's stored in RAM and it is only there while the program runs, which is nice. And we do a lot of things with in-memory data, but we can't use anything pre-existing and we can't keep it around when we're done. So being able to use files sort of solves this problem for us. To make a new project here, this is chapter 6. 6 streams. All right, let me grab the side book as well here. I don't know why they don't have the return. That makes me a little sad, but that's okay. We'll add our namespace. All right, here you go. Oh, that's the wrong one. Too many letters. All right. So input and output streams. We've been using the output stream this whole time with this insertion operator. Seems really funny because it feels like we're outputting things, what we call insert. You're essentially inserting something into the stream. The stream being what shows up in the console here. So when I did cout, that's our standard output stream. Right? Happy Monday. Right? We're inserting this. So this is the insertion operator inserted into the cout. That's our standard output here. That's an O stream. Right? So this is our output stream. So we're inserting into the output stream, and this stuff will show up in the output. So just the wording there is a little funny. And let me grab string. So we can also cin, right? We've used the extraction operator to get text, to get input from the user. We would cin, we'd extract from the input stream number, and then we can cin number, right? We extract the value. So this is our input stream, and this is our output stream. Just to put some names to what we're doing here, right? It's sort of been magic before that. So this one's nothing super new and interesting. It's just putting names to what's happening in these input and output streams. For formatting, that's all fine. You can go back and figure that all out after. Nothing very interesting. If you want, you can input off of a string. So when we've done inputs before, we said there were two ways. We could get the line to get a line of input, or we could see it. When we did get line, we get everything including spaces up to when they hit enter. If we did cin, we would just get the value up until they found a space. So like trying to get someone's whole name would be tricky, right? So if we said enter your name, we'll say full name, right? And I had a string for name, and I tried to cin on name, it's not going to get it here. We include string here, and I can cout on name. Right? Nothing new here. I got to do a number first, don't I? Eric Chernesky. We're only going to get the Eric, right? Because there was a space there. So if we wanted the whole thing, we could use getLine instead. So we could do getLine, and getLine says, okay, now this looks crazy here, all these different functions here. But what is the input stream we're using? So I'm going to use the cin input stream, and where do we want to put it? We want to put it in the name variable. Right? So this gets the whole line, standard input, up until enter key, right? And now I can get everything including spaces. Oops. Yep. Mixing and matching these is ugly. You see it just kind of skipped all of a sudden. So when I said 1 and I hit enter, it ran to the end. And this is why I recommended not mixing and matching. It just causes all sorts of headaches. When you see in a value, it goes until it sees the white space, but it doesn't grab that white space. So the enter key is white space. The space is white space. A tab is white space, right? So it grabbed the 1, but then the enter key that when I hit enter, it was still there on the input stream. So when I called get line says, oh, I see an enter key. Here's your line. But it was blank. So it gets to be a little messy here. So to do that, you sort of just need to get a line and just trash it here. So I see in, and then I don't string for throwaway. We'll add it to throwaway. So this gets the enter key. Let's pressed. Now, the next time I call get line, it'll sit and wait and say, okay, I haven't seen an enter key yet because this one got the enter key. We didn't spend a whole lot of time on this earlier because I said just avoid it. So that's the lazy way. All right, so now I hit 1. Now I can get my full name here and it's good to go because we got the enter key off the input stream. That part make sense? Cool. So not only can we get values this way, but we can take a string itself and you can input off of that string because a string is an input. You can use an input string stream, which is super funny sounding. So if, say, I were to read a file and get a one big line of data out of the file here, let's count with name here. So maybe we had something about like a car, because vehicle are fun. So we might have a string for vehicle info is what we have, like the make, you have the model, usually a year, or is it a year first? People say, or like when you describe your car, you say the year first and then the make and the model. All right. So who's got a car they want to offer up here? 2011 Ford Fiesta. Man, that's a party right there. That was a joke, right? Okay, thank you. Thank you for laughing at my terrible jokes. I guess, sure. So, if I want to turn all of this into individual pieces of information, now I can use the input string stream. So an I string stream. Goodness, this is my, I don't know, vehicle info string. And you can call these anything you want. I think, what do they often use here? They usually say in SS, and I hate that. I hate in SS. But sure, it's your string string. It's not hard to type this, but okay, sure. Um, so to assign that, right, we say, okay, in the parentheses here, we're going to give it the string we're going to convert or use in this string stream. So I give it my vehicle info string. It will turn this into the string stream. How is it upset now? Initializer. No, no initializer. Oh, I didn't do my stream. S stream. There we go. Include my string streams too. IO streams, string streams, and string. I feel like it's a Dr. Seuss book here. We talk about this here. All right. So now it's happier. The red line went away. I did not get the suggestion for importing the S stream. Sometimes it's not perfect, right? You're not always going to get the right light bulb here. So, all right. Now we got our string stream. So I can use that then, and I could have something like, here's my string for the year, here's my string for the make, and here's my string for the model. And I can see in, no, I'm sorry, not off of the CN, I can off of my vehicle string stream, I can grab the year, and then I can take my vehicle string stream, and I can grab the make. I can take my vehicle string stream, and I can grab the model. We can see in off of the inputs string streams here to do that same thing. Now, this doesn't seem very interesting now, but we're going to use this in combination when we read out files because we can read out lines at a time and take apart those lines if we want to as we go. And then, I don't know, here's your vehicle is a year, space, make, space, and a model, and a deadline. So it should get those three pieces that we took apart individually, and we'll just spit them back out here. Again, it's not very interesting. We're not doing a whole lot with them here, but maybe eventually we could do something fun with them. 2011 Ford Fiesta. Fantastic. So we were able to take apart a string and then use those parts however we want it to here, right? Um, so that this will get a single line here as well, right? So we can ask for them to type something in, right? The first name, last name, age on a line, and then exit. As long as we're not done here, we'll get the line. Clear is what we are going to use if you're reusing your string stream here. Clears it out and then resets it essentially. So instead of making new ones of these every time, this is a slightly more proper. Say, hey, clear it out and then set the string to this. It's just slightly more proper here. It's more memory efficient. Instead of trying to make new ones of these every time, we'll just clear it out and set it, clear it out and set it. So it just like kind of says, hey, point to this one, please. Look over here for your input string stream here. And if we exit, sure, we're done. And then we can grab values, output the values, and then we're good to go. So not super interesting here, but we can go through getting one line at a time. And this is generally easier for users to enter. One line instead of something, enter, something, enter, something, enter, something, enter. Right? If they just type it all out in one line, it's a little easier for them. So it's slightly more natural, although you probably don't see very many users typing stuff in the black box anymore in their programs. So again, all of this leaning towards using files. If I can get a file full of data, it's easy to get the line out of the file and do something with that line, right? Not necessarily as much users are going to type something in here, but builds up into using files here. All right. Now, excuse me, we might not know when we're out of data. So you can say, hey, while I can extract data, you can do that, right? Um, so whether or not we've reached the end of the file, this EOF, end of file, I don't know why they didn't just spell it out, but sure, end of file. It's more alphabet soup you can keep in your head. Will be a true or false, whether or not there's more information to read out of the string here. So we're just going to output whatever here, as much as they want to enter, we're going to go and grab their individual name. Now, again, just getting individual names here is not super interesting or exciting, but it's a way to go through all of the data that was entered and do something with it. Right? It's a way for us to process it, and we don't know how long it's going to be. Right? Eventually, we'll get to the end here. So if they maybe like entered a list of scores, this is much more interesting. Right? Enter some numbers, just space separate rather than number enter, number enter, number enter, number enter, number enter. Eventually hit a -1. It's kind of annoying. It's not the end of the world, but as we like prompted users to enter values until they were done, sure, we could just say, hey, just enter a list separated by spaces. So like a little more friendly input style here. We can go through that way. Phone number formats, sure. So clear out your string stream, set it here. If it's good. So this one's interesting. When you ask if something is good or not, where's this one here? It was figuring out whether or not the stream is in an error state or not. As we try and read things, we get into an error state. And then it no longer returns good. Interesting. So you can input multiple things all at once here. So it's trying to get the dummy character, it's trying to get the office code, the dummy character, and the station number. Sure, because office code is the second set of 3 digits. We have the area code, we have the office code, we have the station number. Is that really how phone numbers work? This must be someone really old. This is older than I am. None of this makes any sense. But we read in the area code as a number, right? Because my area code is an integer. So it's going to try and read in an integer. If it can't read in the integer, this good is not set. It's failed the extraction here, and we no longer have this good flag set. They'll say, no, something wrong happened. Hey, you didn't enter something right here, right? So maybe they gave me some parentheses first. So I can get the dummy character being the parenthesis, then I can get the area code numbers, then I can get the next parenthesis, right? And so, okay, is it good? Did that work? And my dummy character are parentheses here. Sure. So we can validate our piece of information here. All right, and then standardize it here. So this gets to be a little bit more interesting. This is a little bit more complex, but dealing with varied input is actually rather difficult. Right? How are all the different ways people might enter values here and having to account for that? Gets to be a lot of fun. That was a fun example. All right. Outputting to a string stream. Instead of the screen, you can output to the O string stream here. So eventually, we'll turn everything into a nice string at the end here. So we can say, hey, take this output string stream, put it all together. Now, this is useful because not everything we're going to do will go to the console, right? Not every time when we need to work with data are we going to spit it out in this little black box here. Because this is not the whole of the world here, right? Not everything gets spit out as a prompt. So if we need to build a string together for us to write to a file later, maybe, perhaps, right? Because we're going to write to a file, then I can build that string out using the output string stream and do all the things like I would before with my other outputs, right? Say, hey, take this one and then add in this one and add in this one and just put it all together here. Eventually, we get the string version. Say, hey, output string stream, give me the string I just built, and then we can do something with it. Now, again, this example just outputs it here, so it's a little silly. But if we were to say write this to a file, now I have one single string I can write to the file, and it starts to be useful here. Okay, so working with these is a lot of fun. So depending on how we want to format our data, we'll do a lot of these. Again, using the S stream include here. We can start building these out. All right. Savings, that's a big string here. That's fine. This one's fun. Look at this. You can figure out how much money you're going to save because you guys have spare money, I'm sure, as broke college students. Yeah, go for it. I'm sorry. I'm not making fun of you. I'm trying to sympathize with you because I know what that's like. You'll get there, though. You'll get there. And um, people on Twitter are just jerks sometimes, which is really weird. But there's like a whole debate going on whether or not you should get into software engineering for the money or you should get into software engineering because you like it. And the jerks are like, no, you can only do this if you have a passion for it and you love it and you have to code inside your job and outside your job and you can do nothing but write code. And most of the same people online are like, no, your job you do for a living, have hobbies. Please don't write code all day long. If you like it, go for it. If you want to do other fun things, do other fun things. So, gets to be a little weird, but that's okay.
I have a question.
Yeah,
So for the uh input stream,
yeah.
um, it inputs all the information, stores it, and then the uh output stream, it outputs the information from the input in string or input in.
So you can build an output string stream
Mm-hmm.
just like you would do couts. So
Okay.
you can turn whatever you would say. Normally, we've been outputting everything here with these insertion operators.
Mm-hmm.
You can build a string with that instead. So I
Okay.
can kind of piece it together. Here's a hard coded string. Here's a variable. Here's this. Here's a variable to build a string, and that string we can do something with later. So we're going to see we can use those strings and write those strings to files. So it gives you a nice way to format it as we're building here, one line at a time, essentially. But you don't need to use inputs and outputs at the same time.
Okay.
Right? This
They're
is
individual or independent from each
yeah,
other.
yeah, they're independent from each other. All right. So eventually, right, they just spit this out here. This produce savings table function. Remember, we don't get rid of things here. So here's our function, produce savings table. Starting amount, annual percentage rate. I don't know why they didn't write this out here, APR, because not everyone knows what APR means. And then the number of years. Like this is not hard, people. Okay, we've got some constants, right? They're output string stream. They know what their interest is, they know what their balance is, and then we start adding to the balance. So they're doing some of the formatting that I skipped over. Formatting is great, right? I just don't want to spend the time on it. I'm sure you guys can figure that part out. Read in the Zybooks. It'll give you lots of practice, don't worry. Uh, and we start adding the interest to the balance, right? Your monthly percentage rate here that we divided by 12, and it's a little awkward here, but sure. Um, and we add that interest, and then we tell you, hey, what it is, and then only if we've hit 12 months do we add this to the output string stream. So we add 12 months worth of interest. Now, this does make a difference, right? This is compounding monthly, not compounding annually. Right? You want to compound as often as possible because it increases your possible returns. Right? If you just get 5% back at the end of the year, that's much different than getting 5% or a twelfth of that every month, right? Because then you're losing the monthly interest you would have earned. It's not a ton, but as you start to have more money, this starts to matter more here, right? Well, we can look at the difference later if you're curious, but uh, this one is a lot of fun. Let's just shamelessly steal this because why not here? Let's take this one here because this is fun, and we'll put this function up here, and I'll even grab the URL for you here because why not? Look at that. I cited my source for that function. I need some more includes, don't I? IO manip, IO manipulation, or input output manipulation. So we get all those sets here. Okay, so that one's fun. We can even ask the user, right? We could say, hey, what's your balance, right? Starting amount, annual percentage rate, number of years. See out the table. Let's grab all these here. Nope, I didn't hit copy. Copy. There it goes. All right, starting amount. So if we just start with $1,000, annual percentage rate. What's an annual average bank return rate? 5.35. 5.35. First merchant. That's an ad though. That's not even an ad, is it? Huh. 0.5%. That's a little bit different than 5%. We'll go with 5% though, right? That's a little happier. So 5. Number of years. Now, I'm sorry? I was going to say 30. 30. So if you're around age 20 or so, for 30 years, that puts you at 50. Probably going to sit around longer than that, right? Because by the time you actually retire, the Social Security minimum, Medicare minimum will likely be 70, if not even higher than that. So that gives you 50 years, right? From age 20 to age 70 or so. So let's put 50 years here because that's fun. So $1,000, if we don't touch it and earn 5% a year, gets up to 12,000. That's not terrible, right? From 1,000 to 12,000. So it's doubled, right? So it doubles here, and then it hits 4,000, it doubles here, and then 8,000, it doubles here or so, right? Okay, that's fun. Um, if you like numbers and those sorts of things, people say the rule of 72. Take your percentage rate divided by 7, or 72 divided by your percentage rate. That's how long it'll take to double, essentially. So 72 divided by 5. I can't do that math in my head here. It's about 14 years or so for it to double. I think that checked out, right? Year 14, we doubled, and then we doubled again year 28, and then 42, we doubled again, right? We double about that rate here. And that's putting $1,000 in and letting it sit, never touching it, never adding anything to it either. So we can make this more interesting, right? So let's go and see if we can make this more interesting. So let's say we need a int for monthly increase, monthly add. I don't know, monthly savings. Sure. How about monthly savings? So each month we'll add to the balance here as we go. Right. Not only will we add the interest, we're also going to add the monthly savings. Right. So if you add $100 a month, right, we'll add that every loop here for every month, right, as we go. So let's ask then for see out. How much will you save each month? And then we can see in we need like a in for monthly savings. monthly savings, right? And we'll add this one in here, monthly savings. And then we'll add this into our function, monthly savings. Okay. So now if we start with $1,000, oh, let's just start with zero. So we've got no money here, and we'll add at 5%. We'll add for this is for 50 years, right? We'll add $100 each month. So $100 a month for 50 years, right, is 100 times 12 times 50. That's $60,000 over 50 years. How much do you think we're going to end up with if we can get a 5% rate of return over 50 years? It's going to be a lot more than 60,000, right? Anyone want to take a guess? Half a million? Anyone else want to guess? 300,000? Okay, less than half a million? Anyone else? What? How much? 100,000?
120,000.
120,000? You think just doubled? Okay, anyone else want to guess? More than how much? More than half a million? Definitely more than half a million. Yep, definitely. All right, you ready? It's super exciting here. Oh, 266,000. But from 100, from 60,000, this is four times doubled? Or no, doubled, I guess doubled twice, right? But four times as much as the original savings. So 268,000. That's just $100 a month here. It's not too bad. Now, the sad part of this, though, is inflation, because your future spending power will decrease thanks to inflation, because that's the fun thing you want to talk about in class. So, inflation is crazy right now. It was pretty stable before, and the Federal Reserve has a target of about 2% per year inflation. Like they actually want inflation, which is a whole other story here. You can get into that in an economics class. But if we were able to hit the target 2% per year, right? So it's 1.02. We want to the 50th here, means that something that costs a dollar now at 2% inflation for 50 years will cost $2.69 in 50 years. So that is not even a gallon of milk anymore. How about a loaf of bread? Can you even get a loaf of bread for a dollar? I don't think so. What do we get for a dollar? Candy bar? You can't even get a candy bar for a dollar, right? Uh,
Can't even go to a dollar store for
the dollar, yeah,
$1.05.
even the dollar store's moving up. But this means that 266,000 really has a spending power. Let's copy this here. Divided by 2.65. It's really only worth 100,000 in terms of spending power. So it'll buy you $100,000 worth of today's goods in 50 years. So you're still better than the 60,000 we had though, right? If you just put it $100 a month in cash away. And this is only a 5% return. So ideally you can do better than a 5% rate of return. This is what the average stock market. Now, average is a really bad number here because this is not how math works. Okay, the average is how math works, but this is not how the stock market actually behaves, right? The actual rate of return varies wildly, right? It will go down. You'll lose money in the stock market. Some years you gain 30%. It's all crazy. It's a bit of a Ponzi scheme as well because there's federal incentives for everyone to invest in the stock market. So it increases demand artificially, but that's another story. So if you can get 10% per year, right? Let's rerun this here for fun. So $0, 10% rate of return for 50 years at $100 a month. Now we're at, oh, we ran out of room here. That's a good thing. Right, 1.7 million. Is that what that number is? 1.7 million. So changing our rate of return significantly changes this number. We went from 260, right, to 1.7 million. So that's the compounding. That's the doubling here, right? At 10%, the rule of 72 says every 7 years or so we're going to double. Right? The more you can double, the better off you are. This was super fun. This was just using their coding example here. This is a retirement savings calculator. And again, divided by 2.65, you get a lot less spending power out of this after 50 years from now, but that's not necessarily anything we need to worry about right now. It will impact you in 50 years. And that's if we can get down to 2% inflation, the target. So it's going to be worse now. So anyway, was that fun? That was lots of fun. So building out this string here, this output string stream here, so that I don't need to see out everything. This table here I can do something with that doesn't always have to show up on this black box console, right? These sorts of things, if I could save it as a file, it'd be much cooler, right? Because then I could take this file and have it around, or I could email it to people and be like, hey, look at all this really interesting data. You should start saving $100 a month because you can scrape together $100 a month right now, maybe later in the future, right? That sort of thing. So, and that is why the federal government tax incentivizes retirement savings, because the earlier you can save, the more time it has to compound, the better off you are. Um, and ideally, in your career, you start making more money later in life. Right? As you get more experience, you're generally more valuable. You can make more money, so maybe you can put away more than $100 a month or so. But that's another story there. All right, where were we? All of that from the savings calculator. There we go. Yay! Now files. We finally get to files. So opening and reading from a file. Super fun here. So when you work with files, you always do three things. You open the file, you read or write the file, and then you close the file. Right? Opening is very important. Closing is very important, and you probably want to read from it or write to it, right? The thing you want it for. But we always need to open and close. Right? Those are always going to happen as we work with our file. So we're going to open the file here with our input file stream or our F stream for file streams here. Then eventually, when we're done with it, we're going to close it here. It tells the operating system, hey, we're done with it, and it's not going to keep it locked or keep it open and let other things interact with it here. Now, when your program stops, it'll automatically get closed, but that's a really bad habit. You don't want to be in the habit of just letting it close when your program stops. It's just bad form. So we got to try and be better than that. Okay. So to open a file, we just call open and you give it the name of the file. It's super cool. So hey, open this file. Let's try it. So let's go and let's see. Let's comment out a lot of this. We don't need to do a lot of that, do we? We'll start it up at the top. So we'll include our F streams here for file streams. F stream. Okay. So we need an input file stream here, and then we're going to try and open a name of a file here. Now, text files are really easy because we can open them up, we can edit them, and we can put whatever we want in them ourselves because text is pretty easy here. So we need an input file stream, and then we're going to try open. So my input file stream dot open, and let's, I don't know, test.txt. And then we want to, I don't know, read something out of it here. So we need an int for a number. And then I can take my input file stream and I can extract the number. Now, a couple other things we wanted to check here, right? So it's checking, hey, if it's not open, something happened. And we finally see something that's not a return zero, right? This return one, something bad happened, right? If I can't open the file, I probably should quit because it's not going to work. And I can give them a nice little error message here. So this is pretty handy here to say, hey, if it doesn't open, let's bail out early before I try and get that number here. So if it fails to open, oops, just that line. If it's not is open, right? The not, so we're inverting that. If it's not open, could not open test.txt, return one. Anything other than zero really indicates an error, right? I guess non-zero means an error. Indicates an error. Indicates, is that a more proper word here? That's what they had. Indicates an error. Okay, so we try and run this here. Oops, build errors. What did I do? Where's my error list? No? Where's my errors? Why? What did it? Aha, int number. There we go. All right, we don't need int number down here then. We already have a number. All right, let's try that. Finally got an error. Could not open file test.txt. Now, there is no file named test.txt. Right? We didn't make a file, so I think this makes sense. There's nothing for it to open here. So for us to go and open files, this is where it gets to be a little weird. The file has to exist where our program can go find it. So I'm going to go and add a new item. I want all templates here. I want uh, text file. You can find it in the list here. It's under utility. I don't know why. This is my shortcut here. We'll call it test.txt. I've added a file test.txt. I wanted to add a number here, right? So let's add 42 and give our file a save. So now I have a test file here. And if I open this up in File Explorer, I can see here's my CPP file, here's my text file, test.txt. Oh, I don't have I did not change my new options here yet. You want to view, don't hide extensions for known file types. This is the most annoying option here that Windows does because it's really annoying for programmers. And we do want to show hidden files and folders. There we go. So now I can see it's test.txt. Before it hid the .txt, because it's like, you don't need to know it's a text file. Windows knows it's a text file. I want to know it's a text file. All right, now let's see if we can get a number. It didn't crash, so it must have gotten a number. So that's cool. So it can find the test file here when we run our program. So if let me run one more time here. Do I get, where's all that output here? Here it goes. So it's actually running our executable from over here and go and find a file, right? It puts us in this x64 debug folder. This x64 debug. Where did my executable go? It's not in there. Is it not there? I thought it left it in there. Did it clear it up? You got rid of it for me. Well, it did have it there for a minute. Must have cleared it out. So if I were to put this test file somewhere else, reading it would be a little trickier, right? So let me move it. Let's go back to test.txt. I'm just going to move it up a folder here to the same folder as my solution file here. And now I hit run, and it couldn't open the file. Couldn't find. Oh, I was in the wrong folder. That's where I was. So here we go. This x64 folder. Debug. Hey, there it is. Okay, there's our executable that I was looking for. So I just run this here, right? You can double click your files. Now, notice it just closes right away. It only stays open here because it's doing this debug thing, right? To automatically close, you can set this option. Our program stops because it wasn't expecting any input. It hit that error and crashed, right? So running it here, it's crashing. So let me take the text file, put it back in here. When I've got it next to my CPP file here, I can run it in debug mode, and we're good. It runs without crashing. But if I go find that executable and I run it here, it's crashing. So it doesn't know where the test file is. So if I copy the test file in here, I'm just going to make a copy of it here. We'll have more than one copy going. If I put it next to the executable, right, in the same folder as executable, now when I run my executable, it runs and it doesn't crash. So when you ask for the name of a file, when you ask to open a file, where it looks is where it's running. In this case, when I double click it, it's running in this folder, right? So if it doesn't have another file in this folder, it's going to crash. When I hit debug here, it actually runs at the project folder, which is kind of weird. So it's a little bit different on where the files exist and where it tries to read them here. Is that a question?
So once I close video and then reopen it to go back to retype or add or anything, the cursor disappears. That's what I'm doing.
I've not seen that before. I'll have to look at your computer in a minute. It should just let you type. I don't know exactly what happened. I'm sorry. We can look in a little bit. So when I put this file in the project here, I clicked on my project, right? A solution has one or more projects. We've only done one project at a time, and that's all we're going to do because we're not that fancy right now. We'll get to more advanced stuff later. You want it at the project level because that's where it runs when you run your program in Visual Studio. Okay. If you want to specify the full path of a file and say, hey, it's specifically in this location, you can do that. So if I were to take my file here, let's pull it out of this one here, and let's make sure it is not here. I'm going to pull it out of this one. I'm going to go all the way up. Let's go just to my C drive here. So I'm going to add a new folder here. So new folder. So C test test.txt. Uh, Generally, you don't want to put files right in your C drive, at least in Windows land. It likes to protect that location. So make a folder first. So this is C:/test/test.txt, right? That's the full path to the file here in Windows land. So if I want to open that file specifically, now notice the backslashes here are escaped, right? The backslash normally means this is an escape character because Windows is fun like that. So you can do \\/ to say, please escape the next character of a backslash. I really want a backslash. Right? That's the Windows pathing. Right? Windows paths get escape escape the backslash character. Right? We talked about this way back when, right? You can do your \n for new line, \t for tab, all sorts of fun characters like that. Uh, sure. So I should be able to open it from this location here. Right? If it does not exist in my project, I got to open this one up again here. Right? Open. Right? It does not exist here. So now when I run, it reads the file. Cool. So now when I go to my debug directory, it's that debug version here that's built x64 debug. When I run this one here, it also runs. It's not looking relative to where it's running. It's looking at a absolute path. C:/test/test. Right. So you can give relative paths or absolute paths. Right. So this is a absolute path. Now, absolute paths get a little screwy though, because if I were to give this executable to someone else, and that's sort of the idea when we write software that other people can run it, right, it's all well and good and fun for us to run our own software. But if I wanted someone else to run this, it won't work unless they have a folder called test and a file called test on their computer, which is maybe not so great, right? Because that starts to cause some trouble. So absolute paths are great for us. It gets to be really weird, especially if you start putting stuff like absolute paths in these folders here. You're like, hey, I really want to find it in this location here. Well, it's in the user's Eric C folder. How many people do you think have a user's Eric C folder? Not very many of us in the world, right? Unless you're also Eric C, right? So actually, I do have a class with another Eric C, and it's the weirdest thing when I get emails from them because it comes from Eric C, and I'm like, what? And I just like have to take a second. I wonder why I'm emailing myself. It's even CH, like their last name's pretty close to mine, which is creepy. Um, but an absolute path to something like this is just terrible. It's not going to work. So most of the time, what we want to do is relative paths. Right? So I just say a relative path. Um, so let's forget the absolute path here and just go back to our test.txt. Test.txt. This most of the time works pretty well. Right? Is that file even in the right spot? Folder. Okay, neat. It put it back. When I double clicked it, it created again and even put the 42 back in. That's really neat. So most of the time, relative is what we want here. And when you send someone software, it gets all packaged up. You don't just email around executables. Usually they get installers and all sorts of other fun things, or it's zipped up, and you can send files along with it. And if you put it all in the same folder, it has a relative path that will just work. Right? It can just open the file and be good to go. So this looks in the same folder where the exe is running. That gets to be kind of fun. Okay, so one more time, let me make sure that's running here. It runs there. It does not run from my debug folder. Folder File Explorer. I wanted this one here, the solution. This one crashes on us here. Now, one last thing we're going to do real quick here. I'm going to find it in here. So this is OneDrive, Documents, GitHub, CIS 150. No, I'm not typing this fast. I'm hitting Tab. Eventually, you'll get to using the terminal. It's lots of fun, I promise here. When you hit Tab, it will autocomplete. It'll say, hey, I started a G. What other folder matches a G? Right? So I'm not actually typing stuff really fast here. It's just showing up for me. Uh, Fall 2023, and then Chapter 6, Streams, right? And then from here, I can go find my debug folder. Here's my solution file, right? I'm looking at what's in this folder here from terminal. Next semester, you spend a little bit of time here, which is a lot of fun, especially in Unix land, because we teach multiple operating systems for our accreditation process. which is fun. So from here, if I wanted to go run that executable, I'd say, hey, let's go find, or I could go into that folder. So the x64 folder, and then what's the next, the debug folder here, and I could call chapter 6, oops, streams exe. And it says, hey, could not open file test.txt. Can't open it. But now I'm in terminal, so there's nothing for it to close. So I just get the output here, right? So if I want to go back a little bit here, and if I go into that directory and run it, I don't have my file here. Hang on. Let me go into chapter 6 streams. So this folder has the test file, right? I'm in the chapter 6 streams project folder inside the chapter 6 streams solution folder, right? We're just doing this at text here. So if I want to go from here up a level and then go into the debug directory, uh, debug, no? Oh no, I want it up a level, up. Come on, go back. It's not working for me here. Debug. Oh, it's x64. That's what it is. That's why. Debug chapter 6 streams. If I run the executable from this folder here, I said, hey, go find the executable that's in up a folder in x64, in debug, in chapter 6 streams, exe. It finds the test.txt file because where I'm running it from here, I'm running it from the project folder. The file is relative. And that's what Visual Studio is doing. When I hit run here, it runs it from the project folder. It doesn't actually run it from the debug folder here, right? It's not in the x64 debug folder when it runs, because then I wouldn't be able to find the file. All this to say relative file paths, right? And we'll spend more time with this. We'll practice with this. It's a lot of fun, I promise. Running stuff in terminal. It's really exciting. I know you love typing in black boxes, so lots of fun. Does any of that make sense? Did I lose you a little while ago? That's okay if I lost you. We'll come back to it. Okay. All right. So relative files. So that's reading files from relative paths, right? Again, checking to see if it was open or not. Oh, I didn't close it. I'm showing a terrible example here. So if it's not open, we read it here, and then we close our file. Close. Close the file when we're done. So I got the number out here, and I could see out red number, number. Super exciting, right? We read the number here. It is, oh, goodness gracious. Oh, it can't open it for, so I think one or two of you have had this error before here. I left the program running. So when it tries to build for running in debug mode, it says, I can't edit this file. I can't change this file. I can't write this file because it's in use. So I need to cancel my run over here. Control C will kill that. Now I should be able to run it here. So if you leave the debugger open and then try and stop and run it again here, sometimes it gets confused. I didn't that time, but sometimes it does. It can get confused easy. All right. So we were able to read a number out, right? I think we read the number 42. Super exciting. Now again, that's just one number. What if we wanted to have a list of numbers here? What if this was like our cash register receipts here? Right, we could have a bunch of numbers here, 77, and 23, and 9, and 1, and 25. I don't know, a bunch of numbers here, right? You can just type numbers in until we're bored. Okay? Probably that one here. So it'd be much more interesting, right, if we did some sort of loop. That idea, as long as we can read data, let's keep on reading data. So instead of reading one number here, let's read a bunch of numbers. So maybe we'll have an int for the total here. Starts off at 0. And while my input stream reads number here, this will loop till it can't read anymore. Reaches end of file. End of file, right? We're going to take the total plus equals the number. And just for fun, I'm going to see out the number, just so we can see what number we're reading here, right? This is just for our purposes to see it here. And then we'll close the file, total red, and we'll output the total. So now we should be able to get all the numbers out, right? Up to the 246, right? That was the last number. I think that was the last one here, right? 246. Yep. So it read all of the numbers here. and total them up for us. So now all of a sudden it feels a little bit more useful. I can give it a file with who knows how much data in it. It will go and read it all out and do something for me. Right? We could calculate an average, we could calculate a standard deviation, whatever sort of fun things you wanted to do here, right? But now I can base it off of a file input. I don't have to have the user type the stuff in, which is so much nicer, right? Because computers are faster, that sort of thing. Hey, just read the cash register file. Don't have the user look through every single receipt and have to type stuff in. Because I don't know about you, but the more often I have to do something, the more likely I am to screw it up. So if I'm typing in receipts, I'm probably going to typo one of them, and then my cash register won't balance, and then they'll be pissed off at me. Right? Did I tell you the funny story about food service workers and cashiers and like people in IT? It's not actually all that funny. Um, but turns out if your cash register is short, a lot of times your manager gets pissed off and they want you to pay for the difference. Like, hey, your cash register is $5 short, you got to pay that. Like, what kind of jerks do that? But this is how we treat our food service workers or people in cashiers all around the world. In IT, it's not common, but it happens where people make mistakes that cost, tens of thousands of dollars because you did the wrong thing and took the system down or deleted the wrong thing and took something offline. And the general response to that is, oh, okay, let's make sure it doesn't happen again. You learn something, right? You're like, this is like tens of thousands of dollars mistake, not $5. And we're like, it's okay, just learn from it, which is the right response, right? Not, oh, you have to pay the difference out of your paycheck. Like we treat people so differently here. It's crazy. There's a whole Twitter thread. Twitter's a fun place sometimes. Of like most costly mistakes people ever made in IT. It's a little bit painful to read, but also kind of interesting to read, like all the terrible things people did. Uh, if you remember, was it last year? I want to say like most of the internet went down because someone at Amazon clicked the wrong button or typed the wrong thing and hit enter. I don't know if it don't remember that. Oh my goodness, it was a huge outage. Was it this? It was uh, Global S3 outage. What was it here? Uh, where's it here? I think it was this one. Oh no, that's 2008. That wasn't it. I feel like it was 2022, right? 20. I think it was 2022. All right, they had a good article about it here, but I'll see if I can find it later for you. This one? No, that was 40 minutes. I don't know. They pressed the wrong button, and they're like, "Oh, we need to make sure that you can't press the wrong button in the future." This is good. It will fix our processes. So that sort of thing. All right, so working with files, right? Open it, read it, write it, close it. We're good to go. Um, Reading to the end of the file, like we just did, right? We read, and so you can also say until it doesn't fail. So remember we said, hey, if it's good or not, you can say if it doesn't fail, and then check whether or not you actually got to the end of the file. This is sort of nice because if someone throws something stupid in your input file, it might end unexpectedly, right, on us. So we can check. This is kind of nice to make sure we are properly reading things as expected. And then when we do stop this while loop, we can check, hey, did we get to the end of the file or not? So if we just stopped because it's bad, we didn't get to the end of the file. And tell the user, hey, something went wrong here. You need to fix your file. Versus our program here, if I throw some garbage in here, is just going to stop. So if I throw in like a 10 here, right, and then we run it, huh, it just stopped reading, right? Because we said, hey, as long as we can read, well, you can't take the word 10, extract it as number, so while loop stops, right? So it's nice to have that check. Hey, if my input file stream dot end of file, if not the end of file here, see out, something bad happened while reading the data, right? Some sort of message here so we can find out, hey, something bad went wrong. Something bad went wrong. Yes, that's good English here. Something bad happened while reading the data. So my total's probably not right. Again, or maybe even just completely skip this piece here. So working with file input, bad stuff can happen, just like we work with user input. But if it's completely automated, we're not going to notice here unless we go and look for it. So you have to be a little bit more careful because we might not even know that we didn't reach the end of the file here, right? Or sometimes if we just, instead of 10 here, if we just have like a blank line, let's see, I think this might work, 246, yeah. The blank line works. It just keeps on reading past it here. That's okay. the way that we extract here. But I think if I have a space here, I think the space will throw it off. Nope, the space is fine. Okay, that's it because we're doing CN, so we'll be able to get it here. So you can work with it. All right. Uh, counting words here. That's all sorts of fun. Business reviews, sure. Input stream errors, right? If a good bit, the end of file bit, failed bit, bad bit, a couple different things you can check for. All right, we're about out of time, so why don't we hold off on output files for Wednesday? So in lab today, we can work all with input files and be reading data out of files. And then next week for lab, we can do the output files because we've got lab next week when we're just doing midterm review, nothing new. So we'll do the midterm review and then the lab will be on output files. We'll kind of split it up that way. Does that make sense? All right, fantastic. So we pause this. Any other thoughts, questions, concerns before we break? All right, awesome.